Perpendicular lines are two lines or two line segments that intersect to form a right angle, 90 degrees. You may also hear the term orthogonal, though it is slightly older. Here we see a diagram of line segments AB and line segments CB. If the angle between A, B, and C is 90 degrees, we say that AB is perpendicular to CB. This means that the line segment AB is perpendicular to the line segment CB, as denoted by the signs. That's an upside down capital T. That means perpendicular or orthogonal.
So we're going to consider here two lines that are actually meeting at this point B. And we're going to consider two other points on each of these lines, point A on this line and point C on this line. And now if we were to measure the angle of if we're going to measure the angle of ABC, we find that that angle measure is 90 degrees. So that means that these two lines are perpendicular to one another. And it also means that they're at a right angle to one another. So we can say that line segment AB is perpendicular to line segment BC. Now, if we consider the slopes of the lines here and concentrate on this line here, where we go down 1 from point A and over 3 to point B, that means that our slope from A to B is negative 1/3 because we're going down 1 and over 3. And if we consider the slope between B and C, we go up 3 and over 1. So that means that our slope between points B and C is 3 over 1. And I'm going to leave it as 3 over 1 and not reduce it to 3, just for to look for a pattern here. So we'll look at another example. And in this example, we're looking at line segments DE and EF. And if we measure angle DEF, we find that it comes out to be 90 degrees again. And once again, we can say that line segment DE is perpendicular to line segment EF. And if you consider the slope between D and E, we're going down 1 and over 2. So that means our slope between points D and E is negative 1/2. And if we consider the slope between E and F, then we go up 2 and over 1. So our slope between EF is 2 over 1. And once again, we're going to just leave it as 2 over 1. So here's another quick example. And we're looking at line segments PQ and QR. And once again, if we measure angle PQR, so this is this angle here, we find that that measurement is 90 degrees. And if we take a look at, once again, that means that line segment PQ is perpendicular to QR. And now if we consider the slope between points PQ, then we go down 1 and over 4 this time. So the slope is negative 1 over 4. And if we consider the slope between points Q and R, we go up 4 and over 1. So this time the slope is 4 over 1. And once again, we're going to leave it as 4 over 1, not shorten it to 4. So we'll take a look at another example here. And if we're considering the angle TUV, well, we find that these two lines intersect to form a 90-degree angle again. And so once again, we can say that line segment TU is perpendicular to line segment UV. Now, if we consider the slope of the line segment between points T and U, we go down 2 and over 3. So our slope is negative 2 over 3. And between points UV, our line segment goes up 3 and over 2. So its slope is 3 over 2. So now we're going to take a look at the slopes of perpendicular lines and see if there's a pattern.
How do slopes of perpendicular lines compare to one another? Let's look for a pattern in the following slopes. The slope of AB is negative 1/3, and the slope of BC is 3 over 1. These lines are perpendicular. Segment AB is perpendicular to segment BC. The slope of DE is negative 1/2. and the slope of EF is 2 over 1. These lines are perpendicular. DE is perpendicular to EF. Are you beginning to notice a pattern? What similarities or differences do you notice in the slopes? Think about it for a second and then compare it to this next one. The slope of PQ is negative 1/4. The slope of QR is 4 over 1. PQ is perpendicular to Q over R. Did the pattern that you predicted continue? Try it on the next one. Slope of TU is negative 2 over 3. Slope of UV is 3 over 2. TU is perpendicular to line segment UV. Look at what happens when we multiply the two slopes. Negative 1/3 multiplied by 3 over 1 is equal to negative 1. Negative 1/2 multiplied by 2 over 1 is equal to negative 1. Negative 1/4 multiplied by 4 over 1 is equal to negative 1. And negative 2/3 multiplied by 3/2 is equal to negative 1. Perhaps this isn't the exact pattern that you noticed, but this pattern does hold for all perpendicular lines. In fact, we say that negative 1/3 and 3 over 1 are negative reciprocals. That may be the pattern that you've noticed. It's simply the bottom number now becomes the numerator, and the old numerator becomes the denominator, and then the sign is dropped. The same follows for negative 1/2 and 2 over 1. They're negative reciprocals. Notice how the numerator becomes the denominator and the denominator becomes the numerator. As well, the sign switches. Likewise for negative 1/4 and 4 over 1, and for negative 2/3 and 3 over 2. Two lines are perpendicular if and only if the product of their slopes is negative 1, or if one is vertical and the other is horizontal. Because remember, the slope of a vertical line is undefined, and the slope of a horizontal line is 0. So the product of an undefined number and 0 is never going to be negative 1. That's why we have to add that specific case. An easier way of saying this, though, is that the slopes of perpendicular lines are negative reciprocals. So all that means is when you have a perpendicular line, take the slope, put the numerator in the denominator, and the denominator in the numerator, and switch the sign. Slopes of perpendicular lines, part 2. Find the slope of the line that is perpendicular to the line negative 3x plus 6y is equal to negative 8. Give this a shot, and when you're ready to see the solution, come on back.